balanced and unbalanced forces. This is a continuation of the topic of forces in Year 7 Science. So previously we looked at forces, what they were, the types of forces, and things like free body diagrams. So there are things called balanced and unbalanced forces. For balanced forces, I want you to think of a seesaw that's balanced like that. And unbalanced, think of a seesaw that's tilted at one end. And that gives you a pretty good idea as to what balanced and unbalanced forces are about. So I'm going to start with balanced forces. Think of a very simple scenario like two people pulling on a rope in opposite directions. So let's say it's you and your mate, and here's a rope that they're holding onto. Suppose the guy on the right is pulling the rope to the right, and the guy on the left is pulling a rope to the left. Now, if they pull the rope with the same force in opposite directions, in equal and opposite directions, the rope is not going to move anywhere. Okay, so let's say there's a mark on the ground. The rope's not going nowhere. It's not going to move left. It's not going to move right. Reason being is the arrows that I've drawn. Okay, let's pretend that they're the same length. Let's say, I don't know, they're half a centimeter. That indicates that the force in each direction is the same, but opposite in direction. So they cancel out. So let's say the force on the right here, let's say it's, for example, 20 newtons. The force on the left is also 20 newtons, but it's in the opposite direction. We usually give them a sign. So think of maths, think of a graph. You've got a plus y-axis, minus y-axis going down. You've got plus x to the right and minus x to the left. That's the standard way of expressing a graph. You've got plus y, plus x, minus x. So because the force on the right is going to the right in the plus x direction, it's plus 20 newtons. We usually don't write the plus at the front, but you know that there's a plus there, right? So if I write, for example, 1 newton, you know that there's a plus 1 at the front of it, right? Same thing. Now the 20 newtons to the left, because it's going in the minus x direction, that's going to be a minus in front of it. So the total force on the rope, what you do is you add them up. So in this case, the only forces acting on the rope are in the x direction. We have to focus on this direction here, the x direction, the horizontal direction. What we do is we always, you can start any way you like, but I usually like to start with the plus numbers. So the plus 20, let's take that, and we subtract the 20 going to the left. So you've got the right force, plus 20, minus the left force, minus 20 there, plus 20 minus 20. So 20 minus 20, that's 0 newtons. Okay, remember, we measure force in newtons. Just as we measure mass in kilograms, we've got, and distance, let's say in meters, we've got newtons to measure force. Okay, so that's the total force acting on the rope, 0 newtons. The reason why it's 0 is because the forces are balanced. Forces are balanced. Okay, they're equal and opposite. Equal and opposite in size. Another way of saying size is magnitude. Equal and opposite in magnitude and direction. Okay, magnitude just means size. Think of an earthquake, magnitude 4.2 versus 8.2. 8.2 is going to be a lot bigger, right? Going to cause more damage. So the bigger the magnitude, the bigger the force. So that's an example of balanced forces there. However, let's suppose that same rope, I'm going to erase this now. So with these videos, you can pause, I guess, and just take notes. Let's suppose now, instead of plus 20 on the right, let's suppose it's plus 30. Let's work out the total force on the rope. Now, what you do is you take the plus 30, okay, and then you minus the 20, because we're finding the total force. You can do minus 20 plus 30, that's fine. I like to start with the pluses always. If you do that in your head or on a calculator, plus 30 minus 20, that's 10 newtons to the right. So in other words, the rope is going to be moving to the right because the 30 is bigger than the 20. So the forces here are unbalanced. So the rope is going to move, in other words. Okay, and I'll explain it again. If I have a 30 newtons force pulling to the right and a 20 newtons force pulling to the left, the total is basically adding them together. But because there's a minus there, it's moving in the opposite direction. Okay, the minus x, minus 20. You get 30 minus 20, which is 10. Now, if I did minus 20 newtons plus 30 newtons, I'll still get 10 newtons, right? But you have to also write direction. 10 newtons is not enough. You have to write direction. It's going to the right. And that's because forces are things that have a magnitude, a size, in this case 10, and a direction, in this case the right. Okay, I'm going to call this the right. I'm going to call this the left. So that, in a nutshell, is balanced and unbalanced forces. I'll do some more examples here. Suppose I've got a box and there's a force acting down on the box 50 newtons and there's a box force acting upwards of 10 newtons. Okay, and if you look at the arrows, the 50 newtons is bigger than the 10 newtons, right? Because forces are basically like arrows. The bigger the arrow, the bigger the force. 50 is bigger than 10. Let's find the total force. Now, another way of saying total force is net force. Think of net profit like in a company. Net profit, how much money you've got left over that you make for yourself. So nets, what you do is, so going back to the graph up here, plus y minus y. Okay, that's the plus y direction going upwards, minus y direction going downwards. Okay, we're only looking at the y-axis here in this case. So the total force is plus 10, that's a plus there, it's in the plus y, minus, because it's going downwards, minus 50 newtons, and you get minus 40 newtons. You can leave it like this. That is the same thing as saying 40 newtons down. Okay, minus 40 newtons means it's going downwards. The total force is going downwards, so the box is moving downwards. So you can write minus 40 newtons or 40 newtons down because the minus means downwards. Or you can just say 40 newtons going down. Let's do another example. Suppose I have a car and it's moving to the left. Let's say there's a force of, I don't know, 500 newtons. I'm making up these numbers. I don't know if they're right or wrong, but anyway, they're just examples here. Suppose there's another force, there's a force opposing that, 500 newtons, going to the left, and let's say it's 100 newtons. And let's also say that there's friction between the tires and the road. Try and draw it just as best I can. So big arrow there. Oops. Slightly smaller arrow and then another small arrow. 50 newtons. Let's find the total force. So what we do is, once again, that's the plus x direction to the right and the minus x direction to the left. That's all we're interested in here. There's only the x direction, the flat direction, horizontal direction. Let's start with the 500, or I should say, let's start with the pluses, the 100 and 50. So the total force is 100, so it's plus 100 newtons, plus the 50 newtons. Okay, it's plus because they're going to the right, minus the 500 because it's going to the left. So if you punch all that into your calculator, or do it in your head, 100 plus 50 is 150 newtons, minus 500 newtons, and you get minus 350 newtons. So the total force, and it makes sense if you think about this logically, the total force is acting to the left because the car is moving to the left, and the 500 newtons is way bigger than the 150 put together. Okay, if you think about it logically. So you can write minus 350 newtons or 350 newtons to the left. Same thing. Both are perfectly acceptable, okay? I personally would recommend the 350 newtons to the left because it tells you the direction there. But that's how you look at balanced and unbalanced forces. You break up the question, you look at the arrows, and you just add the forces